One of the things that, hello, I won't be in tomorrow morning for student hours. I'm going to come in early on Thursday. I'll send out an email. I still have some medical attention tomorrow morning, and then I'll be in on Thursday. I'm planning on being on Thursday, so I don't expect anything other than that. All right, so I've asked just a few questions. Write the equation of the unit circle. Why? This is trigonometry based on the unit circle. So let's look at that. It's all based on that. The unit circle is has this equation, x squared plus y squared equals 1. And if I'm writing it in standard form, so remember from pre-calculus, it looks like that, x quantity x minus 0 squared plus quantity y minus 0 squared equals 1 squared. That's the standard form. And then having done that, what is the center of the unit circle? And what is the radius of the unit circle? Right? So the word unit in mathematics means 1, so a 1's going to be involved there. Right? The center, h comma k, is 0 comma 0, and the radius is 1. So all angles that we will be considering in relation to the unit circle will be in standard form. So the initial side, or the initial ray, is the positive x-axis. The vertex is 0 comma 0, coincident with the center of the unit circle. And then the terminal ray will be whatever the angle produces. Now, there are 2 points on the unit circle that have x-coordinate 3/5. So that is the right half of the unit circle, where x is positive, right? Positive x-axis. So there's going to be 1 point with a positive y, 1 point with a negative y. So x squared plus y squared equals 1. X is 3/5. Therefore, 3/5 squared plus y squared equals 1. A little bit of arithmetic in algebra. Square, subtract, do a little subtraction, take the square root. And of course, here, when there is a quadratic equation, expect 2 solutions, expect 2. And there they are, plus or minus the square root of 16/25. Now, I am not requiring that you reduce all radicals. However, when something is a perfect square, then I would expect you at least to look at it. And furthermore, if you had my calculator, it would just do it for you. So perfect squares, yes. Otherwise, I don't care. And I don't believe Pearson cares any longer. So there are the 2 points. X is 3/5, y is either 4/5 or negative 4/5. We'll see a reduction coming up here in just a second. And here's a question that I would have said you do in class. Now, y is negative 5/5, meaning it's the lower semicircle. Find the 2x coordinates. One's going to be positive, one's going to be negative. Okay, one's going to be on the right side, one's going to be on the left side. And so it's the exact same question. X squared plus y squared has to equal 1. Y is negative 5/2, or excuse me, 5/12. Square, subtract, combine, square root, plus or minus. And the 119 is prime, so boom, there you go. There are the 2 points. Yeah, so y is below the x-axis, and then there's a point on the right and on the left of the y-axis. All right, for this point, confirm that it is in fact on the unit circle. So that's another way that the equation works, is if you're handed a point by somebody and said, hey, this is on the unit circle, hold on just a second, let me check to make sure it is. And then we're going to define all of the trigonometric functions based on things happening on the unit circle. And I see that I have missed something here. The definition of cosecant is, there's a page missing here, and I'll have to fix that. Cosecant of t is defined to be this. Take an angle with initial side positive x-axis, vertex at the center of the unit circle, and then create the angle t in radians, and wherever the terminal ray of the angle, measuring t in radians, cuts through the unit circle, you now have an x-coordinate, y-coordinate. And the cosecant function is defined to be 1 over the y-coordinate. The secant function is defined to be 1 over the x-coordinate. And the cotangent function is defined to be the x over the y coordinates. It's kind of the other way around for, it's the reciprocal for the sine, cosine, and tangent. Somewhere that page is gone. And I'll put it in. But sine of t is just the y-coordinate. Cosine of t is just the x-coordinate, again, of that terminal ray. And tangent of t is just the ratio of y over x. Right? Now, I have put a frowny face here that in the past, the radicals in the denominator were a big issue. It is no longer the case and that it's an issue for me. I think it's not a bad exercise for you to see that you can transform things. You multiply by a special form of 1 because the square root of 10 times the square root of 10 does in fact equal 10, and you get another form of it. I think it's fine. This answer is fine. This answer is fine. This shows a little bit of sophistication that I hope you are taking the opportunity to say, I can do more than the absolute minimum. And that's where I would say this is. It's a little more than the absolute minimum. Right? Okay, again, now, what are the 6 trig functions? Sine, cosine, tangent, cosecant, secant, cotangent. Yeah. So these are, these are trig functions that are on the axes. So here you get to see the definitions of all of them. Sine of t is defined to be the y-coordinate of the point where the terminal ray intersects, crosses the unit circle. And here you see the y-coordinate is 0, the x-coordinate is 1. The tangent is the y over the x. The cosecant of this angle t is 1 over y. 1 over, here's y, 1 over that, does not exist. Secant, 1 over x, it does exist. Cotangent of t, x over y, does not exist. Yeah. And similarly, you have sine of t here is just y, and cosine of t, the angle t, is the x-coordinate. You just look up here. And similarly, tangent and all the others. Yeah. So the definitions are simple. I'm not saying that anything about this is easy. I will in class do just a little more tangible definition of all of these, literal tangible of all of these. But for right now, we're going to look at, these are the formal definitions, of the sine and cosine and tangent and other trig functions. They are just x and y coordinates combined in some way on the unit circle. Yeah. Whoa, that's a little bitty one. Okay. Yeah. Okay, so coterminal. Coterminal means that all of these angles are in standard form. They all have vertex 0, 0. They all have initial ray coincident with the positive x-axis. It's the terminal ray that's different. The terminal ray. And I've picked, I've picked some funny ones. What is the significance of even multiples of pi? Okay. So even multiples of pi means 2 pi. 4 pi, negative 6 pi, negative 10,000 pi, negative 27,987,666 pi. What's the significance of those? Well, here's what I've done. I've taken 19 and divided it by 6, and I've subjected you to long division. Boom. For no good reason. But the point is this: you need to know what the integer part is and then what the fractional part is. So my calculator will do it. I'll just put 19 over 6 in and then press the button that converts it to a mixed number. And I get 3 1/6 pi. Now I'm pulling out, that's a 3 pi, that's 3 pi's and 1/6 of a pi, right? So 2 pi, what's the significance of 2 pi? The angle. This is the radian measure, 2 pi. And I'm left with 1 1/6 pi. And if I reconvert this to an improper fraction, I get 7 pi over 6. And note, these two numbers are not equal. They're totally not equal. They differ by 6.28, blah, blah, blah. But equal in the sense that they are coterminal. They are, in some sense, indistinguishable visually from one another. What's the significance of 2 pi? And here I've said, well, I have 8 pi, yet another even multiple of pi. What is the significance of that? So what this says is that here, 33 pi over 4 is coterminal, indistinguishable from pi over 4. 19 pi over 6 is indistinguishable, coterminal with 7 pi over 6. You can't tell them apart. They look exactly the same. They have the same initial ray and the same terminal ray. But what's with the even multiples of pi? And so I picked one here where you really got to see some long division. I don't know exactly why I did this. I'm not showing off, but I did. There it is. It's 2,551 and 2/3 pi's. So I have 2,551 pi's and also 2/3 of a pi. Well, if I want coterminal, I need even multiples of pi. So I've split this apart and said 2,550 is an even multiple of pi, and that leaves 1 2/3 pi. So this angle, 7,655 pi over 3, is coterminal with the meek, mild-mannered 5 pi over 3. It's not equal to, I've not put equal there.